All right, we're going to try this again. I got through the whole video, then an announcement came on and kind of delayed it. So it says, look at the output values of each table. What do you notice? So we're going to look at both the inputs and outputs. You'll notice the inputs, so your x's are the same along all, okay? Just go ahead and make note of that. And we're going to talk about each table individually. So I'm going to look at this one. I'm going to start over here on the left-hand side, right here. So what I first notice is my x's are all increasing every time by 1. I'm going to put a +1 there because I'm going up 1 unit every time. Now when I look at my outputs, I notice, let's see, 6 to 12, that's +6. 12 to 18 is also +6. 18 to 24 is +6. 24 to 30 is +6. And 30 to 36 is +6. So what I notice here is we are increasing the same each time for both the input and output. This is what we call a constant rate of change. What that means is I'm just doing the same thing. I'm either increasing or decreasing by the same number using multiplication or subtraction. Using addition or subtraction. Okay, so I'm either adding or subtracting the same number. When you have the constant rate of change, or you're adding or subtracting the same number, that is what we call a linear function, which you should have learned about that last year, right? That line in there means it's going to be a line. Okay, so this is a linear function here. So now we're going to move to the second one. I see again, we talked about this, but the inputs are the same, so I see that I'm adding 1 between each one on my x's. But let's look at our g of x, or our outputs here. From 0 to 14, that's +14. Let's see, from 14 to 24, that's +10. 24 to 30 is +6. 30 to 32 is +2. Ooh, and then I go -2. So what I notice here is this is not a constant rate of change, because over here we are not adding or subtracting the same thing. In fact, we'll even notice here at the 30 to 32 to 30, I went up and then back down. So this, if it's not constant, it's what we call non-linear. And this, you probably don't see the pattern right now, but there is one there. And we'll talk about it down the road later in the semester. But this is actually a specific type of nonlinear function. It's called a quadratic function. Okay? And it's the one, it's going to have that U shape when you graph it, or that parabola. All right. So our last one here, once again, we're just adding 1 on the left-hand side in our inputs. But here, I do notice that I'm adding something different. See, +2, +6. But what I want you to think about is, and I'm going to give you a second, is there a pattern here? Can you see some pattern that's happening? I'll give you a hint. Don't think about addition. Think about another operation. All right, so you may have paused the video, whatever you needed to do. What you may have noticed, 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So this is, again, a non-linear function. But since we are multiplying by the same number every time, this is what we call an exponential. That's where you are multiplying or dividing by the same number. And that graph will look something like that, meaning it's getting bigger and bigger really, really quick. We'll talk more in depth about those later, but it is worth looking at right now. So you can go on to the next slide, and I'll see you then.